Imagine you are standing on the bank of a peaceful mountain lake. There is no one around you except a small boat inside that lake. This boat has people on it, and you could also see tiny ripples that come from the general direction of the boat towards you. The question is, are these ripples caused by the possible motion of the boat itself, or could it be that perhaps the wind is carrying large masses of air, and alongside those, tiny ripples are induced in the otherwise still surface? Well, we answer very similar questions in exoplanet detection. One of the most common methods is to detect exoplanets through the radial velocity method. If you could imagine a star and a small planet that goes around that star, the planet itself would induce a small gravitational force onto the star, causing the star to be a little bit tugged along the way. You would observe that the star itself is oscillating with minute velocities to the order of meters per second, an everyday human gait. And from that, you can suppose that there may be a planet around the star. Less massive stars would be pulled more by the same planet, but at the same time, they can exhibit varieties of activity, for example, eruptions or spots along the surface, similar to what we see on our Sun. Such events cause signals in velocities that can be mistaken for real planetary signals. And what my PhD project does is to measure velocities of stars and then mathematically model the random patterns of stellar activity in order to look for actual planets. I measure stellar velocities from our most precise instruments around the world, which can achieve accuracies of just 10 centimeters per second. That's the motion of my waving hand. And through those velocities, I try to separate their complex stellar activity to unveil any planets that orbit those stars.